My name is Professor M.V. Malkanamar, Department of Physics, Government First Grade Women's College, Jamkandi. Now, I am engaging BSc First Sem class. The name of the paper is Mechanics and Properties of Matter, Session 4, Unit 1, Frame of Reference, Session 4, Non-Inertial Frames and Fictitious Forces. Now, first we have to discuss the frame of reference. A system of coordinates whose axis can be suitably chosen is said to be a frame of reference. For a location of point P, we need three coordinates in space, that is x, y, and z. For complete identification of an event, we must know time also, therefore t, that is the time of occurrence. Hence, an event is characterized by four coordinates x, y, z, t. A reference frame describing an event in these four coordinates is known as space-time frame. Consider a body of mass m. We will observe its motion from three different frames. We will observe the motion of a body in three different frames. First, we have to consider the body is at rest. The acceleration of the mass will be denoted by a rest. Therefore, the force on it will be F rest equal to m into a rest. That is, we are assuming that the particle is, the frame is at rest. Therefore, mass into acceleration of the body a rest when the reference frame is at rest. Now, observe the diagram carefully. Frame O with origin O, axis x, y, z is at rest, and another frame with origin O dash, axis x dash, y dash, z dash is also at rest in the first case. Now, both frames are at rest. Therefore, force acting on the particle F rest equals to m into a rest. Now, consider the second case. Assume that reference frame S dash, that is with origin O dash, is moving with constant velocity v. The acceleration of frame A equal to 0 because it is moving with constant velocity. Therefore, acceleration of the frame A is 0. Thus, the acceleration of mass m relative to frame is given by A inertial equal to a rest minus a equal to a rest because a equal to 0. Now, force on it will be F inertial equal to m into a inertial. Now, you know in the above expression a inertial equal to a rest. Therefore, m a inertial equal to m a rest. m into a rest equal to F rest, that is force acting when the frame is at rest. Now we have to consider the reference frame moving with constant acceleration. Let the acceleration of frame be a frame. Thus, acceleration of mass relative to frame will be a relative, that is Observe here carefully. The first frame is at rest, second frame is moving with an acceleration a. Therefore, acceleration of mass relative to frame will be a relative equal to a inertial minus a frame. Now you know a inertial equal to a rest. Therefore, a rest minus a frame, that is acceleration when the frame is at rest, acceleration when the frame is moving with an acceleration. Therefore, force on mass will be m into a relative, that is relative acceleration. Observe here carefully in the above expression, a relative equal to acceleration, relative acceleration equal to relative acceleration equals to rest. When the frame is at rest, at that time acceleration. When the frame is moving, that acceleration. Now m a rest equal to m mass into relative acceleration equals to mass into rest acceleration minus mass into frame acceleration, that is f rest plus m into minus a frame, that is f rest plus f pseudo. Observe here carefully. When the frame is moving with an acceleration, force acting on the particle f equal to force acting on the particle when the frame is at rest plus force acting on the particle when the frame is moving with an acceleration. F pseudo indicates force acting on the additional force acting on the particle when the frame is moving. We see that the force is not the same as that in the inertial frame. Therefore, we postulate that under observation from an accelerated reference frame, we substitute the inertial forces on the body with those same inertial forces plus an additional force which numerically equal to the mass of the body under observation times the acceleration of the frame taken in the opposite direction. This force we call as pseudo force or fictitious force. When the frame is at rest, there is no acceleration. When the frame is moving with a constant velocity with respect to the other frame, again there is no additional force. But when one frame is moving with another frame with an acceleration, and an additional force is acting on the body, appears to be acting on the body, that is equal to the mass of the body under observation into the acceleration taken in opposite direction. This force is known as pseudo force or fictitious force. Observe here carefully. A frame of reference either at rest or moving with uniform velocity is known as inertial frame. All the laws of physics hold good in such a frame. Non-inertial frame is nothing but a frame of reference which is either having uniform linear acceleration or being rotated with uniform speed. If the body is moving with uniform speed and if the body is moving with linear acceleration, then the corresponding frame of reference is known as non-inertial acceleration, non-inertial frame. In a non-inertial frame, laws of physics do not hold good. For example, consider a car turning with a constant speed, say to the right. The passengers inside the car feel as if they are thrown, that is forced towards the left relative to the car. Physicists would say that you are going in a straight line, but the car moves to the right, and there is no real force on you to the left. The force acting on the passenger is a fictitious force arising from the use of the car as a frame of reference. If we take the car as a frame of reference, then that additional force appears. Let us concentrate on people in a car. Passengers instinctively use the car as a frame of reference, while a physicist uses Earth. The physicist chooses Earth because it is very nearly an inertial frame of reference in which all forces are real. In such a frame of reference, Newton's laws of motion takes the form given in dynamics. The car is a non-inertial frame of reference because it is accelerated to the side. The force to the left sensed by a car, the force to the left sensed by car, passenger is a fictitious force. Passengers sensed by a fictitious force having no physical origin. There is nothing real pushing them left. The car as well as the driver is actually accelerating to the right. Okay, thank you to one and all.